Number 21, an object, little m, is tied to one end of a string, moves in a circle with a constant speed v on a horizontal frictionless table. The second of the string is connected to a big mass, big M, goes through a small hole in the table. What's the value of big M if it stays in equilibrium? Well, if it stays in equilibrium, the force that's exerted on one has to be equal to the force exerted on the other. All right, so let's sum up the forces for the little mass, little m. So when it's all the way at the left side, it has a tension force directed to the right. Naturally, its weight is going down and its normal force is going up, and its acceleration is directed toward the center of the table. So the summation of forces for little m is summation of forces equals little m times a, and the only force that's working in the radial direction here, which is what we're concerned with, is the tension force. So we have tension force equals little m times a, and in circular motion, little m times v squared over r. So we know what the tension force is there. Now let's look at a free body diagram for the big mass. Big mass. So here's the big mass. We have its big M, g, going down, and its normal force going up. It's not moving up or down, so its acceleration is going to be 0. Whoops. Sorry. Mistake. No normal force. This is tension force because it's not in contact with the surface. So if we sum up the forces now in the y direction here, we have mass times acceleration, but we said the acceleration is 0. So we have tension force going up minus big mg equals 0, or the tension force equals big M times g. So we know if this is going to be in equilibrium, which is what they're looking for, we need to set them equal to one another. So the tension force for the down-hanging one is going to be equal to the tension force for the little guy. So let's see, we have little m v squared over r, and that has to equal big M over g. And they're asking for the value of m, big M, so m is going to equal little m times v squared over gr. And that looks like choice A.